I welcome Andrew Fried for this podcast. This is a kind of a podcast where I'm just trying to convey what is this all about, the conversational AI and the NLP. There's no difference between that, and we are just demystifying what's the structure of the language in the brain, and we're just trying to understand what is it all about when we are architecting something which is using language. And I'm very glad that Andrew sir gave this podcast to me because I feel glad that he was able to get the book out, the conversational AI and the chatbots, because I think probably demystifying how a machine can talk and a human can talk probably is going to give us a lot of insights about the AGI that we are craving to build. And thank you so much, Andrew, sir, for giving this podcast and means a lot.
Absolutely. Glad to be here and glad to help us learn.
Yes. I just wanted to ask you this one question is deep learning the state of the art machine capability that we were actually fond of exactly before TensorFlow got open sourced? Like, was it all about the deep learning which was hyped? And now today it's a kind of a hope. But I wanted to understand, like, is it the ultimate state of the art capability that a machine can really give out?
Yeah, so interesting question. Deep learning is essentially the most computationally intensive of our techniques, right? And you've really seen it pick up now that we have the amazing compute power with the cloud and such. But it's also, it's not always what you need, right? So it sounds really cool when you say the name deep learning. It's a great name, right? You think I need to get me some of that. But that's not always the right tool for the job as well, right? So when we talk about chatbots, oftentimes it's not really deep learning under the covers. It's often a simple text classifier.
But like, how are we really understanding what's the requirement of the hour? Because I don't think so that we are actually catering to the need. Like sometimes I feel like most of the deep learning research that we are doing probably is dumb enough not to be using deep learning because it's a kind of a mundane job and probably a simple algorithm can do that. But how are we understanding it? On a scale of 1 to 10, how much is the requirement of deep learning to the today's world? 1 being the least, 10 being the highest, and also on a scale of 1 to 10. How is a human's understanding about deep learning today, according to you? Because that might really give an intuitive thought about a different perspective from a researcher and a professional whom you have seen altogether. So I just want you to answer these questions.
Sure. So certainly from a hype point of view, 10 out of 10, right? It's the coolest sounding thing that we've got. And some of the use cases that you see coming out for AI, that they're really amazing. Yes, absolutely. It's deep learning under the covers. So if you think about, I'm sure you saw Copilot, right? The tool from Microsoft that'll write your code for you. Or there's tools like WriterMe, which will you get a little text, right? And then it'll fill out the rest. Like it'll write your whole email or your whole blog post or, whatever. A lot of deep learning under the covers on that kind of stuff. The challenge, or one of the challenges with deep learning, is the explainability, right? How did it come up with that result, and how can you influence it? And in a lot of these use cases, you don't really know, right? You have to just kind of throw your hands up and say the algorithm did it, right? And you maybe can describe a little bit what the algorithm looks like. Hey, it's this kind of a neural net and there's so many layers in it, but can you really come back and say, well, here's exactly why it came up with this, right? And that becomes a little bit challenging when you're throwing in, deep learning with millions or billions of features, right? You can hardly pull out a human understandable explanation.
Yeah, I just wanted to understand what is conversational AI to the world, which is very new to it, because it's not new kind of a stuff that we are just pondering upon. Like, hey, this was just a myth, and today it's a fact. Conversational AI happened for a very long time, and in fact, most of the research, when you think of early ages, it was all psychology and the things like that. So to the world which doesn't know what is conversational AI, And if world is so familiar, and you have seen a lot of researchers and every person, so I just wanted to you to actually give this insight on what should be unlearned from the researchers who are doing conversational AI today, because there's a lot of hype about it, but nobody
Yeah.
knows where to reach and what to learn and everything. So if you can address that, that would be awesome.
Absolutely. So what I think about conversational AI, it's that the technology is coming to the user rather than forcing the user to go to the technology. So a lot of people are familiar with an automated phone system where you call in and it says, hey, press 1 for this and press 2 for that. And they hate it, right? They hate it. And they say, oh man, I don't want to trust AI. I don't want to trust automated technology because it's such a terrible experience. And, think of the systems, how they almost aggressively waste your time, right? They give you a very long preamble that doesn't help you at all. And it's a long time till you can figure out what do you need, right? How do I get to, like, if I want to make an appointment, I have to wait till they said, hey, press 5 for appointments. I had to listen to all that other nonsense, right? And the reason that is it's very easy to program it that way. It's a very simple rule, right? You press 1, press 2, plus 3, very easy. Contrast that to a conversational system where instead of giving you this long nonsense greeting, then press 1 for this, press 2 for that, it just says, how can I help you? Right? And right away, you can say what you want and you can get to the right place. And that's the difference, right? You're going to use, hey, if you want to make an appointment, or hey, when can I come in? Or, I want to see the person at so-and-so. You're not pressing 5, right? You're saying what you want the way you want it, and the technology is figuring it out and getting you there. That's the major difference.
But what are we supposed to unlearn? Because there is a lot that we have learned over a course of time, and there is a lot of hype over what we have learned also as well. Like, hey, tomorrow the algorithm that you're probably deploying can go obsolete, and nobody might actually be interested in using that tomorrow. And like when you think of something like Jovan Schmidhuber and the other guys who came up with this LSTM, SVM, like Vladimir Vapnik and all these guys, right? They were all denied about the fact that this is a state of the art architecture that we are just giving out to the world. It's a math which has everything. But many conferences rejected and a lot of things happened. But today it's a state of the art. So I just wanted to realize from your side, like, how much should we unlearn in order to just build a sustainable AI, which is more secure, which is more compatible, and which is more user friendly?
Yeah, so I'll give you a couple angles because I think different people need to unlearn different things. So for perhaps the less technically inclined, I would unlearn what you think machine learning means. I joke that it's the coolest sounding 2 words that you can put together, or it's right up there, right? I mean, machine learning sounds awesome. And generally people jump right to Skynet, like, hey, this thing is learning on its own, and I just turn it on and walk away, right? And most of the approaches that we use are ultimately a supervised approach. Supervised meaning we are providing the answers to the machine, and it's reverse engineering how to get to the answers. So from one side, I would say you unlearn what you think those words mean. But from the other side, there's a tendency to say, oh, if only we made the algorithm a little bit better, right? That we're going to throw more technology at it, and maybe we're going to tweak the features, or if only we had more CPU, more resource, we can run it faster, better, stronger. And there's an inclination to look at it purely from a technical point of view. And I would encourage those to step back and say, well, let's not just consider the technology, let's consider the people, right? So bias is a huge problem with AI. If you feed in biased data, guess what you're getting on the other end? You're getting a biased algorithm. No matter how good your algorithm is, how much you tweak the neural nets, what have you, bias in, bias out, right? And a lot of folks have a hard time understanding the idea of unconscious bias. Oh, that's not something that applies to me. Well, of course it applies to you. We're all biased, right? And the whole point of unconscious bias is that you can't see it, right? So For the more technical crowd, I would suggest, consider that whatever you're feeding into the system, you're essentially amplifying it, right? So when you do any sort of automation, the pro is that you're doing something faster, right? But if you're biased before, now by automating it, you're just biased faster. So it's a great opportunity when you're introducing this kind of technology to take a step back and say, well, wait a second, how am I, how am I training this, et cetera. If you think of a recent example in the news, there was a company that was in trouble for hiring. They had put an AI in charge of the hiring, and it turned out that it was rejecting all of the women, or not all of the women, but it was very biased, right? It was hiring way more men than women. And they went back and looked at the training data. It turned out, well, they looked at who they'd already hired, and they already were hiring way more men than women, right? So you could decide how much blame do you put on the AI, but there was not a consideration of, hey, wait a second, this data we're putting in, is it fair, or is there a bias in that data already?
Yeah, that's true. That's true. Because a lot of times, we don't understand what is that all about. Even Charles Isabel and like Michael Littman, they have really evangelized that, okay, there's a code there, there's a module there, you can still copy the code, but do you know what's there inside the data set? Do you have the insights about the data set? And I feel that that's actually a point in which every data scientist thinks about, like after some sort of an experience, they say that let's not focus too much on code, let's just focus on the data which is also there. So on a philosophical note, like there is a huge tension in every person. Like, what if AI goes rogue tomorrow? What if AI just decides and says that, hey, I just made a mistake, I'm very sorry for that, and it costs billions and billions of dollars? What if it's a demonic, and like a lot of things are coming up? So I just wanted to understand, like, what's the structure of language in our mind and the brain, because it's different. Not everybody can understand the same language that the nth person might talk. Like somebody like I say in India, and my colloquial language is different, and you say somewhere else, and that's a different language. And so I just wanted to realize, like, what's the structure of the language, because they just give out the insight and the intent, but the way in which it's being talked and delivered is different. So what's the structure of a language in a brain and a mind?
Well, very strong question, I gotta say. Well done. So part of what we hope to accomplish is, when we're training a system, to not just train it on the way that I speak and the way that you speak and the way that our friends speak, but to really go around and get those different perspectives, just to give the opportunity to see all those things. Because if you don't see them, you don't have any chance at all, right? A certain pattern or a certain way of speaking. So you definitely want to go around and get the different perspectives. Ultimately, in a lot of these algorithms, all you get is you provided inputs and the outputs. And again, it's reverse engineering. It's finding a path, to get from the input to the output. There's no guarantee that it's the path that you would use, right? And that is one of the great challenges of AI, right? I was actually talking to somebody at IBM recently who said, turned me on to, I think it was Polanyi's paradox. I'll have to look up the exact spelling, but the idea was, for most tasks, humans can't actually explain how they do it, right? There's a lot of things that you just do, and you couldn't tell me the steps that you actually used. You may be able to tell me steps that you think that you used, right? But probably not the ones that you actually used. So overall, it's a challenge and often a bad idea to just let the AI, go by itself. And it's much better to consider it as a tool that helps humans, right? So you don't want it to make a life and death decision on its own, certainly. And if you just think about something that has, less and less consequences, hey, maybe you let it have a little bit more leeway, right? But it's much better to think of it as a tool that augments humans. If we have a conversational system and it doesn't understand what you're asking, well, you may not get to that last, you may understand like 90% of the users, 95%, maybe 99 if you're awesome. There's always going to be some set that you won't understand. And it's important to design a way out, right? So the very simplest one is, again, you're building like a phone AI, let the users get to an agent. If you've misunderstood them 6 times in a row, don't ask them a 7th time, right? get them to an agent. And by the way, don't go 6 or 7 times, maybe after twice, get them out, right? So again, it's at some point, it's not purely something you're going to fix with the technology, but you want to have that, human insight as well.
Yeah, but we are trying to build a kind of an artificial human inside a machine that actually costs $9, something like that. Because we are talking about edge deployments, and we are actually not completely, it's not edge, but there is an invasion of the cloud to some or the other ways. Like internet is always there. And I'm looking at the threat of it because I'm a DevOps guy who looks at the superficial aspect of targets that we are deploying, like hundreds of them where we are deploying the same old model. And every model is prone to make some sort of a black box attack, or else can be of anything. Like the model can get biased and noises can be added and so on. So I'm looking at the security aspect of it. But human is the worst link, according to me. It's not the machine which can be torn apart. It's just a single human. Like probably you can do a phishing attack and get a company down, and that's always there. So I just wanted to realize, like, how far are we efficient in getting a more secure conversational AI? Because you can see some examples, like Tate Tweets had a worse nightmare. Like it was a state of the art to one extent, then afterwards it started learning something else, and the tweets were kind of frustrating to some guys and also frustrating to the data engineer who really designed that. So I just wanted to realize, like, how far are we efficient in getting and more secure and a more reliable AI which is more sustainable for the world tomorrow, because it needs to keep learning no matter what, because patterns are just changing. The way which we had before the pandemic and way which we have after the pandemic is different. So I just wanted to realize, like, how are we building an AI which is more sustainable for future?
Yeah. So, you say these cool words, AI and machine learning, and, again, you might think, oh, hey, I don't have any problems now, security, don't have to worry about it. All this, other typical software engineering practices, it's AI, why do I need that? And it turns out, as I'm sure you know, all that stuff still applies, right? You still need, the security on your devices. You still need repeatable processes to build this, to monitor it, to deploy it, all that kind of stuff. And, we're starting to see more discipline in that kind of thing. So, hey, you want your AI to learn in some sort of, supervised or semi-supervised mode, some sort of reinforcement mode. Well, hey, you better keep running some sort of test set against it, right? And tracking your performance, checking your models for drift and for bias. Like, how are they performing? Not just when you built them, but hey, every time you update, it's just like in software when we run regression tests, right? You got to regression test your model as you change it. So all of those kinds of practices, they still apply. And you see the names coming out, like DevSecOps and AI ops and ML ops, whatever you want to call it. The point being is, just because you have AI doesn't mean you get away from that stuff. You have perhaps a different flavor of it, but if you look at it from a high level, all that same stuff still applies.
Yeah, but there's a beginning of everything, right? But when we are talking deployment at scale, vision model has their own way of being deployed. Like there's a way in which the data comes in, there is a way in which the data is being interpreted. But when I see visual BERT, I feel it like it's a state of the art on steroids. It's something like it has language, it has vision, and it has everything combined together. And people are making amazing discoveries with it. Like they're training, of course, it can be tuned, it can be trained over a course of time. Of course, transfer learning is always a part of it. But I read a thesis from Fei Fei Li from Stanford, and her PhD thesis actually pertains more kind of a visual bird, which is also a very kind of a description about how human cognitive capabilities are working. And when I see visual bird, I feel that we have actually surpassed that. Like it's actually much more better than a human capabilities, what I feel about. So of course, when you go for super glue, there is a ranking for that. GPT-3 was hyped, but it still is not the best in the super glue ranking. But we are adhering to the fact that okay, this is one of the best models that we could get, and
Yep.
so on. So I just wanted to realize, like, what are we developing more towards? Like, are we just giving language that understanding for capability, or else what is it all about when we are training so many data sets, training so many models, giving out to the world, and the way it's being used as well? So what do you feel about all the things that are benchmarking towards a new AI that we are supposed to be building?
Yeah. So, I mean, you all these great examples you list, you can see that it's getting better and better at, you pick your task or you pick a benchmark and, more things are happening. The thing I find perhaps even more interesting is that it's getting easier and easier to use, right? I mean, if you want to do something with neural nets 10 years ago, like, I don't even know how you would get started, right? But if you want to have GPT-3 write a resume for you, there's like a dozen websites where you just punch in a little bit of text and it pops right out for you. So for me, that's what I find the most interesting about it. As we make it easier to consume, more and more clever ideas are coming out of it, right? So I've been in the Watson group at IBM for 10 years, and it would have never occurred to me to have an AI write a resume for me. It would never cross my mind, right? And that's having spent, a long time doing this stuff. But now that it's, more consumable, people are doing those kinds of things. Another example with chatbots, when we started with our platform and very other similar platforms, we would tell users, hey, for every intent, you have to get me 20 examples for that intent. And they have to be super varied, and you have to put in some misspellings because your users are going to misspell things. And 20 examples, that's really hard for someone to come up with for a chatbot, and that's one intent, right? So you never have just one intent. And now when you train these things, hey, after five examples, you get pretty decent results. Your results are always going to get better with more. But years ago, for me to say, oh yeah, you only need 5 and you'll have pretty decent results, I would have never guessed that, right? So and I'm willing to say now, I bet you they'll get it less, right? I bet you they'll figure out how to do it with less examples, never zero, at least not in my opinion. But that's just one example of how we're making it easier, right? And as it becomes easier, more people can do it.
Yeah, when you talk about something as conversational AI, NLP today, I think Hugging Face is basically doing pretty amazing in terms of what they could actually deliver to the world of NLP or the conversational AI. There's auto NLP. You need not have to do much today. Everything is sorted and everything has their own ways of working. Like you just need to know what is supposed to be the job of that model, like where do you want to deploy it, how do you want to deploy it, what's your strategy towards that. And Hugging Face has actually created a new benchmark for all these things that we are talking today, and it's open source, and like it's a firm which is actually building. And if you think of something like GitLab is also open source, and it's a multi-million dollar company right now. So I wanted to realize, like, what's the potential of making an AI open source, because I don't know what's the actual potential of it. It's not AI. The GitLab is not AI, but it has huge potential. But Hugging Face is AI, and it has huge potential, and it has potential beyond it as well, because it can be tuned according to your requirements. So I wanted to realize, like, what if everything is open source, and what are we building it towards, and the learning that we are getting. So I just wanted you to point out to some of those things, because it might help some of those guys who are tinkering with the things, and they can really get motivated.
Yeah, and of course the great thing about open source, you can see right in, right, and you can get as deep as you want to go. So one of the fun things I did when one of the book chapters I did was to build your own classifier, and I just wanted to demonstrate, how you would go about it, right? Because if you use any of the major commercial engines, the classifier is hidden from you, right? Your only interface is the training data, which is in one sense nice because it's easy, right? But you really don't have any of those knobs and dials. And so it can be informative to learn how stuff works by building it yourself. So I did a brief exercise with, I think it was some scikit-learn libraries to put together a classifier you could put into a chatbot. And I walked through, okay, well, here's how it learns from your first couple of examples. And then I went and added a bunch of examples. But in the end, the classifier I built, wasn't that great, right? Because I did like the simplest possible version. But provided some pointers to, well, hey, try these other things, because a classifier and a chatbot is usually not just one step. There's usually, they run a bunch of different features and tokenizers and whatnot over it. And if you're open source, you can go try it out yourself, right? And maybe you'll discover, hey, there's this 8th step that I'd really like to try out, and for me it works really well. Well, the world's your oyster. You can do it when you've got that open source. So a lot of we see well, more technology than before. I mean, there's more open source than when I started in the industry anyway, many years ago. I don't know that we'll see that everything goes to open source, but there's certainly been a trend.
Yeah, that's true. That's true. We have seen that abstraction, like what the guys in Stanford, MIT used to do like 15 years before the AI and ML. I think probably we are just doing it today because of the abstraction. Because TensorFlow is actually having a huge set of compute code, which is actually there in their backend, and it's actually doing it. And Keras is actually doing good. And you have been doing a lot of research on NLP because of your book, because of your day-to-day work and everything. So are these abstractions going to really make us lazy? First thing. And the second thing is, are these abstractions secure according to you? What is it all about when we are trying to build something which is more sustainable for the world tomorrow?
Yeah.
But we are actually moving towards what is actually available. So how do we define the same old abstraction that we have in our hand, use it in a very effective fashion?
Yeah, so first on abstraction, it's a concept that often makes people nervous, especially when they're good at the lower levels. So when I was I went to Penn State University, I started in 1998. We did our homework in C. And some of the old timers like, you know what, I remember when we did this in assembly. You see kids are pretty lazy, right? And by the time I graduated, Java had come out, and they're like, well, wait, you don't have to manage your memory anymore? Like, how is that supposed to work, right? And I did Java for a long time, and now you're seeing low code, no code kind of stuff, right? And more and more stuff is being abstracted. Well, what does that mean? Yes, you're not freeing your own memory anymore. Well, you're sacrificing maybe a little bit of efficiency, right? But think about all of the security vulnerabilities of the 2000s. It was like buffer overflows and like not freeing your memory. So maybe it's not so bad to have lost that. And the other thing that I learned in my schooling was there was a study done that a professional developer can write 5 bug-free lines of code per day. And what was interesting about that study was it didn't matter what language you used, right? So you could write 5 lines of assembly, 5 lines of C, Java, Lisp, what have you. And so the more expressive your language is, or the more of that low level you can abstract, the more you can get done. right? So, in the small, yeah, there might be a little bit that you're, not able to do because of that abstraction, but ultimately, your languages become more powerful. You could do more things with them, as well as it's easier. And again, when something's easier, more people can do it. You get more ideas. So overall, I think it's a positive thing.
Yeah, I know. By building something using conversational AI, are we building something to understand about humans itself? Because I feel that more we are trying to make humans attached to a machine, more they are learning. And somehow we are just getting that cognitive insights that we were supposed to be discovering. Like we are actually, I think to me, DevOps is a discovery because I failed it in many times and I was like, no, this is not mine. And in deep learning, I just failed 6 times in deep learning. I was not able to understand. And one fine day I just see all the researchers and they were like, we don't know many things. We still learn. And
Yeah.
that was a Kickstarter for me. And I was like, yes, I'm going to do it no matter what. And that just evolved over a course of time. So I just wanted to understand, like, what is this abstraction all about that we are talking today? Like we are building something and are we discovering something new about the cognitive and the capabilities of the brain? Because brain uses less power, more compute, and that's what we are building towards. And what's your take on this? What are we learning by building a conversational AI bot? By understanding language, can we really go very close to an AGI? And can we understand an AGI system, build it more effectively using what we have understood using the conversational AI? So it's all yours.
Yeah. Yeah, so I wouldn't be surprised if you could start making those kinds of connections. I gotta say that's not the path I typically think about. And again, a lot of these systems, like, hey, I train an AI to do what a human does, but I may or may not know how it got there, right? So I don't know how much that tells me about the human performing the task. Other than perhaps to say, hey, that task looks really hard, right? You must have to be really smart to do this. But what I find is when we're using AI to analyze things about people, so like people who are calling into a conversational, when they are interacting with an AI and I'm recording and analyzing what's happening, I'm getting the real view. Whereas if previously it was human to human, and I asked one of the humans, well, how did it go? They brought their own, perspective, their own biases, their own emotional state, what have you. They think they're giving you an accurate representation. Like they're not lying to you, right? They really, whatever they tell you, they believe. But that doesn't make it true, right? So what I find interesting is things that we would have loved to tap for insights before, now we're able to do it. So if you think about like a call center, they always tell you they're recording all the calls for, monitoring and training purposes, right? But think about what sort of awful task it must be to go through hours and hours and hours of calls every day. But they're not listening to all of them. It's not a human listening to them. But now they could, apply an AI system because, hey, it doesn't get tired, right? So run it overnight, right? Have it transcribe all of your calls, run some analysis and find some trends for you. That's something that's unlocked to you that before, you had the data, but you couldn't do anything with it.
Yeah, when you see GPT-3 is in every place. It's now there in Excel. It's now there in Power Apps. Of course, Microsoft was part of the GPT-3 program. They gave the compute for it to train that kind of a model and everything. Like, there's a huge demand for such kind of an deployment that we are actually desiring towards. Like, and many people have come up with their own applications as well. But to me, when I see that kind of a deployment, that doesn't scare me up because I think we are very close to falling in love with a computer. It's something like, I just love you for no reason. I don't know, we might not have a baby together, but I feel like I'm in love with you. And that might be the situation. I scare that one day, probably it can happen one day. But I wanted to understand, like, if we build an AGI, what are the questions that it can answer? Because AGI is considered as one of the most super intelligent species if we build it, and
Hmm.
a lot of things are there. So I just wanted to realize what can we just build using an AGI. That's fine, but what it can answer is my question. And also, if you are successful in building an AGI, what's your first question that you're going to ask for that AGI system? I know this is
Oh
a
man.
fun question, but it can
Yeah.
be
So
very
I,
informative.
I'd probably poke on the edges and see if I could, trip it up, or, uh, see a little bit. Hey, what is it actually learning here, and how is it going about it? Um, I guess you could call me a bit of an AGI pessimist. Um, I see that we're having great success doing targeted trainings for one task or another, and we're great at some tasks that we thought were, hey, they would require the artificial general intelligence, and then just kind of brute force it, right? So like look at chess and checkers. Like, I mean, yeah, we won, right? The computers won, but really it was just because they could, memorize all the books and replay all the openings way faster than the humans could. It was just a pure brute force play. So yeah, in my opinion, it's hard enough to train for a specific task. So I don't think anytime soon we have to worry about the AGI. It would be cool to be proven wrong, but I don't see it anytime soon.
Yeah. But what's your first question? Because I really am very curious about it, because a person who has seen conversational AI and the potentials of it, but what if it gets the ultimate intelligence? What are the questions that you are going to ask? Maybe one,
Yeah,
two, three. How many questions that you want to answer?
maybe I like feed it my book and ask it what I got wrong. Right? I think that would be a real interesting one. Or yeah, that was a great question. So actually, the other thing I've been interested in, just continuously learning. I think about, hey, what should I read next, or what should I learn next, and that might be an interesting exercise to say, hey, here's what I've been doing. Where do you see the gaps, right? Because again, I can self-assess, but I may have a misunderstood picture of that. So yeah, I would probably ask it how I could improve myself. I think that would be nice, safe. There's not too much harm, not too much harm I'm introducing to the world if I do that. So I think that might be a nice place to start.
Yeah, I think, yeah, thank you so much for having talking to me and just conversation with me with a lot of insights actually, because I'm not an NLP guy. Trust me, I don't do NLP for a regular basis because it's tough, but it's very, very intuitive because it has a lot of possibilities that it can be the next future of whatever we are building towards. And I think thank you so much for such great insights, sir. And this podcast was awesome.
Absolutely. So glad to do it. And if your listeners are interested, I would love for them to check it out. So conversational AI, and I understand you'll put the link in the notes. So it'd be great if anyone wants to learn more about how they do it. Would love and love to hear feedback.
Yeah.
What you learned, what you're going to do with it. Show me the projects that you're doing. I'm interested to see what people like you do with it.
Yeah. Thank you so much, sir. Thank you so much.